Okay, so welcome to this lesson of chemistry. So today's lesson will look at the periodic table. So the periodic table, as the definition is saying, the periodic table is a chart of elements placed according to the order of increasing atomic numbers. So in chemistry we learned about in grade 10 work we learned that there are some elements. You even draw the table showing about 20 elements. Now the periodic table now gives you the clear picture of elements, that they are not just 20, but they are more than 20. And it's a chart that shows the elements that are there beside that the 20 that you learned in grade 10. So we are saying that this is a chart of elements placed according to the order of increasing atomic numbers. So, and from your grade 10 work, you learned that atomic numbers, this is the number of protons that are found in the nucleus of an atom. That one we know. So, and it is always, if we say this is X, for example, here we have, this is X, then we have A, then we have Z. This is the atomic number. This is the atomic number. We are saying this is the atomic number. That's what we are saying. So the way they are placed in the order that they are increasing atomic number. Okay? That's what they are saying. So further, we can say that the atomic number is the property of elements used to place them in order of the periodic table. So atomic number in chemistry, when you're dealing with periodic table, is very, very important. Very, very important. So this is the periodic table. So look at the important features of the periodic table. The important features of the periodic table. It's an interesting topic actually. So the features of the periodic table. So the periodic table, it has groups. The periodic table has groups and also has periods. So it has groups and periods. Now, when we talk about groups, groups are columns. Groups are columns. So groups are columns, whereas the periods are rows. Okay. So then we know that, at least we know that when we talk about column, it's supposed to be vertical. Columns supposed to be vertical. Then rows supposed to be horizontal. At least that one we know. Okay, so now we come here. So groups, the way they are, groups, they are labeled in Roman. Let me put it this way: they are labeled using Roman numerals. Roman numerals. Okay, let's look at this one. So we are saying that groups, they are columns, so meaning like this. Okay, then periods like this. So now if we check here, this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. That's what we are saying. So we are saying that when you're talking about groups, it is row, it is columns. Okay, these are what we call groups. Okay, so we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, or group 0 if you like. So those are the groups. And you label them using Roman numerals. Okay, that's about groups. Okay, so if you go to group 1, what are the elements that are in group 1? We have lithium, sodium, potassium, rubidium, calcium, francium. Okay, then when you go to group 2, we have beryllium, magnesium, calcium, strontium, barium, radium. So you continue just like that. Okay, but and then when you go to group 3, you see there is boron, there is aluminium, you continue just like that. There's carbon, there's silicon. I'm just mentioning a few. When you go to group 5, you find the metals that are the elements that are very interesting, which is nitrogen, phosphorus. When you go to group 6, you can just go through and check out group 6. We have oxygen, we have sulfur, we have silicon. You continue just like that. In group 7, we have fluorine, chlorine, bromine, iodine. You continue like that. Then group 8 or group 0, we have helium, neon, argon, krypton, xenon. You continue like that. So this periodic table as grade 11, it is yours. Go through it, research on it, master some of the elements that are there. But the beauty part of the periodic table is that you are given in the exam. It is there at the back of the paper. It is there. You are given. But that does not give you the mandate to say, no, I should not master some because it is there. No. At least you save some time that you go to check. You just go, I know sodium is this is Na. So these are the symbols. These are symbols for the elements. So the elements here are not written in full. They are written in what? Chemical symbols. So the other chart that I will bring, it also have names. So it is easy for me to know that this one is lithium, Li, this one is sodium, Na, and so on and so forth. Okay? But here we just want to look at some features, then we'll go detail by that. So now, let's look at this. There's the one that I've not talked about. This part here, which we call the transition elements. Transition elements, the elements that are in here, why they were put on this block, which we sometimes call it a D block. We sometimes call it a what? A D block. The reason is that these elements, they have different valences, and a valence helps us to place them in the groups. Now you find that these guys, they have what we call different valences. So the same copper, we say copper can have the valence of 2, and the same copper can have the valence of 1. Now, in which group are you going to place them? So it's better those that have different valences, just put them on the middle here. So otherwise, what we are saying is that groups, they are only 8. Okay, these that are just here, these are transition elements, and we will talk about them in the other lessons. Now, what I want to talk about is very, very important. We want to know why lithium was placed in group 1, sodium was placed in group 1, beryllium was placed in group 2, magnesium was placed in group 2, boron was placed in group 3, carbon was placed in group 4, nitrogen was placed in group 5, oxygen was placed in group 6, and fluorine was placed in group 7, and neon was placed in group 8 or group 0. So the reason is this. So we'll look at lithium. So if I take lithium, Li, the notation is that the mass number is 3, the mass number is 7. Let me even do this. So we talk about lithium, Li, the mass number is 7, the atomic number is 3. So therefore, if we write the configuration, it will be 2, 1. Let me go to sodium. Sodium, it's Na2311. If I write the configuration, it's going to be 2, 8, 1. Now, have you noticed something here? I've noticed that lithium, the number of electrons in the outermost shell is 1, Even in sodium, the number of electrons in the outermost shell is what? Is 1. So therefore, and we even check that if this is the number of electrons in the outermost shell is 1, even this one is what? Is 1. Then it is placed in group 1. Oh, then we will say that the number of electrons in the outermost shell determines the group number of the element. That's what we can say. Okay, so now let's prove. Let's go to group 2. Group 2, I'll go for magnesium. So magnesium is Mg, then it will be here it's 24, then here is 12. So the electron configuration, so if you have issues on how to write the electron configuration, just go to the YouTube channel, go and watch the one which is written electronic configuration lesson 1 and lesson 2. Then you understand what you are doing here. So now here to be 2, 8, 2. Now the number of electrons in the outermost shell, it shows that it is in group what? It is in group 2. Why? Because of the number of electrons that are in the outermost shell determines the group in which the element will be placed. Okay? So that's what we are saying. So that's about that. So okay, so therefore now this is the work problem that you have to solve, then send in the WhatsApp group. So show using the electron configuration the group in which the following are placed. These elements: A, we have boron; B, germanium; C, chlorine. So we end here. So I've even put the mass numbers and atomic numbers to make work easier here. So boron is the mass number is 11, the atomic number 5. Germanium, the mass number is 73, the atomic number is 32. Chlorine, the mass number is 35.5, then the atomic number is 17. Otherwise, thank you very much.